Welcome to Web Server Workshop. In today's video, I will talk about how the HTTP protocol works, and we will dissect the requests and responses that the clients and servers use to communicate with each other. Although configuring a web server usually means just setting some configuration items, having a solid understanding of the HTTP protocol can make your job easier because you will know what configuration item does what and how the responses from the web server should actually appear. With a strong background in HTTP, you'll be able to troubleshoot misconfigured web servers by narrowing down what it is doing, which might indicate which configurations are not done properly. If you do any web programming involving the backend, a background in the HTTP protocol can help you develop better applications because the applications need to generate HTTP responses. The HTTP that we see in the browser's address bar stands for Hypertext Transfer Protocol. The protocol was initially designed just for the purpose of transferring HTML, the hypertext, from a server to a browser, but it has become a very important standard, and most things on the internet these days speak this protocol. The protocol was initially released in 1991 and has only gone through 4 revisions during the past 34 years, which is pretty impressive for anything tech related. The first version, 0.9, supported just the ability to get pages, which of course is what we think of when it comes to browsers fetching HTML from the server. Version 1.0 introduced the ability to send data from the browser to the server in terms of forms and for uploading files. Version 1.1 introduced persistent connections, which allows multiple files to be retrieved in a single TCP connection, and this became the standard version for HTTP, and this is still used today. The changes made to version 2 in 2015 was to support a binary version of the protocol and to allow multiplex requests, providing a big speed boost. Version 3 was essentially designed by Google in an attempt to mitigate congestion problems on TCP networks. Not many websites actually use HTTP version 3 yet, but over time more will. Let's have a small website. I decided to create this website with a couple of pages, an image, and a basic CSS file. Let's go and visit the site to see what I have. My server is sitting at 192.168.68.20, so I will type http://192.168.68.20 into the browser address bar. I'll show you the HTML for this page over here on the server. I need to connect using SSH, and we will change into the var www HTML folder to take a look at the HTML file. Yes, there really are 6 cats at my house, so these are not fictitious made-up characters, but their jobs certainly are. The only job that the cats do is make noise while I'm trying to record the videos. I've added one page to my website for the cat called Bobo. Clicking on the link shows me the details about Bobo, including the photo, and there is some CSS which is used to make the photo quite a bit smaller. In the world of HTTP, there are 2 pieces of software required. On the left-hand side, we have the client. We call it the web browser. On the right-hand side, we have a web server where the HTML is kept. The web server could be something like Apache, Nginx, or Lightspeed, which is where we'll spend a lot of our time in our videos. In terms of the HTTP operation, when you type something into the address bar or click on a link, the browser creates an HTTP request asking the server to send some HTML. When the server receives the request, the server will look to see if there's some HTML in a file that it wants to send back as a result of the request and creates an HTTP response containing the HTML. Once the client gets back to the HTML, it will now render the page, which of course means take the HTML and display it to the user. One thing that is important to note here is that requests always originate from the client, never from the server. If the server wants to send something to the client, it must wait for the client to request it. There are clever techniques such as WebSockets which can allow the server to send back data directly to the client without waiting, but that's outside the scope of this video. We can now look at what an HTTP request actually looks like. The request shown here is an application level request carried over a transport layer such as TCP/IP. If we were to type http://192.168.68.20/ into the browser bar, then the browser would send a message similar to what I've shown here. The request contains 3 sections. The first section is called a header. The very first word of the header is pretty indicative of what we are attempting to do, which in this case is to get something from the server. Immediately following the get is the resource we want to retrieve, which in this case is a slash, which will be interpreted by the server as the file index.html at the document root folder on the server. You might not see the trailing slash in the address bar when you visit a website, but even if it's not showing, the request is always the slash unless the URL contains something else. The final item on the first line is the version number of the HTTP protocol that the client will be using to send the message. Another thing that is required by most servers is the host line. The host line is the thing from the address bar that is typed between the :// and the trailing slash. After the header comes a blank line. The blank line is a requirement for the HTTP protocol. The final part of the request packet is the body. There's nothing here in this particular example, but if you were to use HTTP for filling out forms or uploading a file, then you would find information here. Here is a typical response from a web server. The response follows the same format as the request, where we have a header, a blank line, and a body. The header in a response contains different things than what you find in the request. Instead of an instruction of what to get, the response includes information indicating whether the request was fulfilled and, of course, the information that was being asked for, such as the HTML. The first line in the response contains the version number of the protocol, which in this case is HTTP 1.1. The second item is the response code. The number 200 means that this was a valid request and that the server is responding with something as expected. The final part of the first line is a description of the response, which in this case is OK. The actual description is completely irrelevant. That's just something for people who are looking at headers to understand. I didn't include all of the lines that would be typically sent by a web server so that we could focus just on the few that were easy to understand. The second line in my response is the date that the response was sent back. The header also contains the type of the server, including the operating system and the web server software and version number. The last two lines in the header are quite critical here. The content length indicates how many bytes will be found in the body, and the content type indicates the type of data that will be found there. In this case, the server has sent back 558 bytes of HTML. The content length indicates that there is a body. If you got a message without a content length, then it means that the body would just be ignored even if it was sent by the server. The first page that we loaded from our site was trivial. It consisted only of a single HTML page and nothing else. Real web pages, however, contain multiple things, so let's look at the other example page that I have on my site. This page contains an image and a CSS file, and looking at the HTML for the page, you can see that the CSS is listed at the top of the file inside the style folder. The image down here is bobo.jpg inside the images folder. To load this page when we click on the link, the browser first creates a request for the bobo.html file. The request is sent to the server, who would then look at the files inside the document root folder, which happens to be var www.html, and a response packet with the HTML would be sent back. The HTML would be examined by the browser, and the browser would find that there is a CSS file and an image file that are both needed to be loaded in order to display the page. Here, the browser decided to load the image file first. The resource is listed as /images/bobo.jpg, indicating that the image should be found in the var www.html images folder. The server then sends back the actual image. The content type in this case is image/jpg. Finally, the browser requests the CSS file, again inside the style folder, and the server responds with the CSS file. Now that the browser has all of the data required to show the page gets displayed to the user. I have here a tool that I created called the Manual Web Client. This was a teaching tool that I developed to completely expose the HTTP protocol so that my students could see what requests and responses look like on actual servers. Let's see how requesting the main page for my website looks inside this tool. The first thing required is the IP address of the server. The transport layer is TCP, and of course we will be sending our request to port 80. In the request box, I am going to type the HTTP request. We will be using the method get. We follow this by exactly one space. Then we will ask for the index.html file. The final item on the first line is the version number of the protocol. We will also require a host line directive, which is just the IP address of the server for now. Next, we must have a blank line. The right-hand window is a preview window showing the carriage returns and line feeds. I included this because during classes, students would often end up forgetting to include the blank line at the end, and this preview window allows them to see whether or not they remember to put it in. Once the request is finished, you hit the send button and you get back a response from the server. The response consists of a header, a blank line, and a body. The response here is essentially the same thing that we showed a few minutes ago on the response line, the date, the server description, but there's a whole bunch of other things that I didn't show. Let's ignore these for this video and look just at the content length and content type. Below the blank line in the body, we have the HTML for the page. Although my tool is really helpful to be able to see HTTP requests and responses, you don't actually need it. Chrome has this built in. When we click on the link to load the page about Bobo, we know, at least from the animation earlier, that there were 3 requests. Right-clicking on the page and picking the inspect window from the browser opens up the developer mode. The network tab shows all of the requests that the browser makes. We will disable the cache here because this will interfere with my demonstration, and we'll cover caches at a later time. When we refresh the page, we can see the 3 requests, one for the HTML file, one for the CSS file, and one for the image. Clicking on bobo.html shows the detail of this operation. The tab Headers shows the headers for both the request and the response. I normally do not use this feature, but the raw option will show the actual headers that were sent and received. We can see the get/bobo http/1.1 and the host line. There are many other things that were also sent by the browser, but like before, we're going to keep this as simple as possible and we'll just kind of ignore them for now. Scrolling up, we can see the response that came back with a 200 OK message. The content type and the content length is as expected. The second request was for the CSS file. You can see the request and the response in the same way. Finally, there was a request for the image. Again, the request and header have the same attributes, and the image type is listed as JPEG because the browser, of course, needs to know that it is a JPEG because a PNG or SVG file or some other strange format that we haven't talked about would have to be rendered in a different way. Hopefully this video was helpful for somebody. If you found it useful, please click the like button and hit the subscribe button to see further videos.